All right, we are going to find some values for our standard normal curve. Standard normal curve means it's symmetric around the middle, which is at 0, and the z-score is the number of standard deviations you are from the center. So on this table, it's going to give you what the z-score is and what the area to the left is. It's always the area to the left. If you want the area to the right, you would do 1 minus whatever the area that's corresponding to it is. For example, if I have a z-score of negative 1.85, which would be on the left side of my 0, the area under the curve is 0.0322 or 3.22%. If I'm exactly at 0, 0's right in the middle, I'm going to have 0.5, which is 50%. And if I'm at a positive 1.85, my area is 0.9678 or 96.78 would be to the left side of a z-score of 1.85. So in order to find the area to the right on this table, you end up having to take 1 minus the area to the left. So for example, on our technology activity, the first question wants us to find the area to the right of 1.11. We would scroll down to 1.11. If I find 1.11, 1.11 says the area to the left is 0.8665. To find the area to the right, we are going to have to do 1 minus that. 1 minus 0.8665 means that the area to the right of that is 0.1335. All right, to use the graphing calculator, you're going to use the normal CMD function. Let me get to the main screen here. And so you are going to hit the second function button and then the VARS key, the VARS key, which is right here. You'll notice the distribution menu is under there. That's the one you're going to want. So you are going to hit second function, VARS, and number 2. Number 2 gives you the normal CDF function to do your normal curve. So I'm going to do number 2. And it's going to ask you for the lower, the upper, the mean, and the standard deviation. Now your mean and your standard deviation aren't going to change. Your mean is going to be 0, that's the middle, standard deviation of 1. Your lower limit, if you're going to the left, will be negative E99 for negative infinity. If you're going to the right, will be positive E99 for upper infinity. So in this case, we wanted to the right of 1.11. So my lower limit, I'm starting at 1.11. Since I'm going to the right, my upper limit is that E99. In order to get that, you have to hit the second function button and then the EE, which is above your comma, and then you'd put 99 behind there. So you're going from 1.11 for the lower to E99, a mean of 0, standard deviation of 1. It'll paste that into your formula for you. When you hit enter, you get 0.13349. So 0.1335, which is the same thing we got when we took the table and did 1 minus the value from the table. Now on the Aleks calculator, if I go ahead and pull up the Aleks calculator over here, here's the Aleks calculator. You will notice on the Aleks calculator that you have P of Z is less than. So again, this is going to give you the value to the left, just like you get in the table. So if I do the P of Z is less than, and I do 1.11, it's going to give me that same value that was in the table. If you can look and see at 1.11, you get 0.8665. So what we would have to do is take 1 minus that value in order to get the area to the right. So on your graphing calculator, if you know you're going the area to the right, on Aleks you're going to do 1 minus the P of Z is less than or equal to 1.11, and then it will calculate it all together, and you get 0.1335. So the area to the right, both on the table and on the Aleks calculator, you end up taking 1 minus the area that's given on the table, because that's the area to the left. Now, if you want to find the area to the left, which is the next one, of negative 1.93, then we can just look at our table. And so if I look for negative 1.93, if I go right here, is my negative 1.93. You can see that you get 0.0268. On your Aleks graphing calculator, same thing. This is doing the area to the left. You can see that it says less than or equal to. So if I'm less than or equal to negative 1.93 on the Aleks calculator and I hit equals, you can see that I get the same value, 0.0268, which was the same value here, 0.0268. If I'm going to do that on my graphing calculator, again, I'm going to go to my distribution menu. So I'm going to hit second, and then I'm going to hit the bars key. And I'm going to do number 2 for the normal distribution. This time, my lower limit is going to be the negative infinity. So I would do negative, second function, the comma to get the EE 99. So negative infinity is negative E99 to my value, which was negative 1.93. Again, the mean and the standard deviation are going to be 1. And when I enter that in, you can, whoops, it didn't like me because I used the subtraction instead of the negative. I got to try that again. Second function, distribution menu, number 2, and make sure you use the negative on the bottom, not the subtraction. I'm used to the Casio that lets me cheat. Negative infinity, so negative EE99 to negative 1.93. Now when I enter through that and paste it in, you can see I get the exact same value that I got when I used both the table and the Aleks graphing calculator. So area to the left is pretty straightforward. You go negative infinity to the number, or you use the less than or equal to, or use the table. If you're doing the area to the right on the table and the graphing calculator, you have to do 1 minus that value. Now, if you want to find the area between two numbers, on your graphing calculator, it's pretty easy to do the area between two numbers because you can just put in the lower and the upper limit. So again, I would hit my second function and the distribution menu and do number 2 to get my normal. And if I want to do between two numbers, I'm just going to put in my lower and my upper limit. So I'm going to do between 2 and 2.47. So 2.00 and 2.47. And if I enter through there, got those in there, my area in the middle is 0.0159. So if I round that off, 0.0160 would be my value. And so on the graphing calculator, pretty easy to do between two numbers. If you are using the Aleks calculator, what you would do is you would take the bigger one minus the smaller one. So I'm going to clear this out. I'm going to do the P of Z is less than my higher limit, which is the 2.47. Whoops, my calculator disappeared on me. Get that back up here. Where'd it go? There it is. 2.47. And then I'm going to subtract the lower one. So I'm going to do P is less than or equal to the 2.00. So the bigger one minus the smaller one, and I would hit equals. And you can see here again, I would have 0.0159. And since that's a 9, I'd round that off to 160. 0.160. Now if I were using the table, same kind of thing. I would find the upper one first. So I would go ahead and find the area at 2.47. So 2.47, I would use 0.9932, 0.9932, And then I'd subtract the other one, which is the 2.0. So if I find the area from the 2.0, it is 0.9772. So I'd subtract that 0.9772. And then you can see when you get your answer there, you get 0.016. The extra 0 doesn't need to be on the end, so it's not on my calculator. But that's the way you would have to do it on the graphing calculator. You can just do put in your lower and your upper. On the Aleks calculator, you would take the upper one minus the lower one. I'm going to undo that so you can see it. Upper one minus the lower one. Same thing in the table. You would look up the number that corresponds to the upper one. You'd subtract the number that corresponds to the lower one. And all three ways, if you round them off to 4 decimal places, pretty much give you the same answer. So the other way, besides asking you for the probability, is they're going to ask you for the percentile for your normal standard deviation. Either way they ask it, if they ask probability or percentile, they're really asking you for the same information or the same values. The probability and the percentile are going to give you the same numbers. So again, you're going to use your second VARS key and the normal CDF. Now if they give it to me the other way around, where they have the area under the curve and they want to know the z-score that corresponds to that, then you're going to use the inverse normal. So I'm going to go ahead and bring that up here. Let me find that. Okay, we did all those. So if you're going to find the percentile or the z-score, second function, VARS key, number 3 is the inverse normal. The inverse normal, you are going to put in the area to the left of the z-score on the calculator. So on here, if I am trying to find the z-score, so the area under my standard normal curve is 0.9671. On my graphing calculator, let me go ahead and clear that out. Again, I am going to use the second function button, which is the blue one, the VARS key to bring up my distribution menu, but this time I'm going to use number 3. Number 3 says the inverse normal. I'm doing the opposite of my normal, so I'm going to put in the area. Again, you see the mean and the standard deviation are equal to 1. So if I am looking for the area to the left of 0.9671, or the area that's 96.71%, I am going to do 0.9671. My mean is going to be 0, my standard deviation is going to be 1, and I paste that into my formula and I hit enter, and you can see that you get positive 1.84. Normally they'll round off your z-score to 2 decimal places, so 1.84 would be the area that would be to, or the standard deviation that would correspond to an area of 96.71%. Now on the table, what you have to do is you have to find the value that's closest to the number that you're looking for. So in this case, I'm looking for 0.9671. So I'm going to look here and I have a 9678. And then if I go way down to the bottom, oh, it does, is exactly. There's my 9671. My area is 0.9671. You can see the corresponding z-score is 1.84. So you would look at the area column and then go back to the z-score over there on the left side of that column. If I am using the Aleks Calculator, again, I got to get that out of the way here and get that on top. On the Aleks Calculator, you are going to use the Z sub button. If you're going to the right, you're going to use the positive. If you're going to the left, you're going to use the negative. So I would have negative, and I want the Z sub, and then in that box I'm going to put the area. So 0.9671. And then when I hit equals here, you can see it gives me that same z-score, 1.84, when I round that off to 2 decimal places. So if you're going to the left, you're going to put the negative in front of that. If you're going to the right, you're just going to leave it alone, use the positive value. So if we look at the next one there, I'm going to find the z-score. So the area under the standard normal curve to the right is 0.8962. So if I'm finding the area to the right, I want to do 1 minus that value because the calculators are all going to the left. So if I'm using my graphing calculator, I'm going to turn it on. Again, I'm using the inverse normal. So I am going to do the second function, the vars key to get the distribution menu, number 3 to do inverse normal. And for my area, since I'm doing it to the right, I'm going to do 1 minus that value. So I'm going to do 1 minus 0.8962 to get the area to the right. And I'm going to enter through that. And you can see that I get negative 1.26, negative 1.26. So if I were using the table, it'd be the same kind of thing. I would do 1 minus 0.8962, which gives me 0.1038. And I'd look for in my table the 0.1038. So up at the top here, 0.10. 0.1038. There it is, 0.1038. You can see it gives us the same value, the negative 1.26. Negative 1.26 is what we have corresponding to that. So if I'm finding the area to the right, I'm going to do 1 minus that value, both in my inverse normal and if I do my table. If I'm using the Aleks graphing calculator, since it's the area to the right, I just use the z sub. So I'm going to use z sub and I'm going to put in the 0.8962, 0.8962, and when I hit equals here, you can see I get the same number I got, excuse me, when I use the graphing calculator and the table. So graphing calculator and the table, I have to take 1 minus that number. Aleks calculator, I just do z sub that number. It does the right. So it's a little different than the table and the Aleks graphing calculator would be. Losing my voice. All right. The next one, it says what we're going to do is we are going to find the z values, one positive and one negative, that are equidistant from the mean so that the area in the two tails add up to 10%. That means the area in each tail would be 5%. So in order to find the area to the left, we just do inverse normal 0.05, which is our 5%. So again, I am going to do the second function button and then the vars. And I'm going to do number 3. And so the area to the left of 0.05 is going to give me negative 1.64. Negative 1.64. If I wanted to do the area to the right of that, then I would have to do 1 minus that. So again, second function, the vars key, and number 3, and I would do 1 minus 0.05, or you could just put in 0.95 if you actually subtracted it, and you get positive 1.64. So the area to the left is negative 1.64 standard deviations from the middle. To the right, since it's equidistant, positive 1.64 standard deviations from the middle. Same kind of thing on your Aleks calculator. If you want to do the area to the left, you have to do negative z, and then you'd put in your 0.05. Gives you your negative 1.604. If you want to go to the right, you use the positive z. Whoops, I'm going to clear that out. Positive z and the 0.05, 5% to the right. and you get the positive 1.6 or 1.64. Those two numbers should be the same, plus or minus. If my area to the left and to the right are the same score, I'd have negative 1.64 standard deviations and positive 1.64 standard deviations. All right, the next one says I want to find the area between 0 and C. And in this case, I have my area as 0.4175. My z-score is going to be to the left side of that area. So I know up to 0 that it's 50%. 50% would be half of my normal curve. I'm going to find the area to the left of z, so I'm going to find the area that is in the white part. And so what I'm going to do is take my 50%, my 0.5, and subtract my 0.4175. What I get is 0.0825. So what I'm going to find is I'm going to find the area to the left of 0.0825. Again, I'm just going to use my inverse normal. And so I'm going to use the second function and the bars key to get my distribution menu. I'm going to do the number 3 for the inverse normal, and I am going to find the area that is to the left of 0.0825. And when I enter there, my z-score that corresponds to that is negative 1.39, because I have to round that off to 2 decimal places, negative 1.39. Again, on the Aleks calculator, it's the same kind of thing here. I'm going to clear that out. I am going to do the area to the left side. It's going to be a negative z-score, and so I'm going to do negative z sub. And I could just put in 0.5 minus the 0.4175, or I could subtract it first and then put in the 0.0825. But just to show you, I can do my math in there if I want to, and then again, rounding it off to 2 decimal places, negative 1.39. So when you're using these calculators, you want to realize you're always going to the left of your bar when you're thinking of the area. So depending on what's shaded, you may want to have to subtract it from 1, or in this case from 50%, because I'm just going from the 0 and not from the whole thing, to figure out the section that is shaded. So on Excel, if I am finding the area under the standard normal distribution curve, the area to the left of a z-score of 1.99, what I'm going to do in a blank cell is type in equal, and then I'm going to do the norms, N-O-R-M-S, distribution, so D-I-S-T, norms dist. I'm going to double click on that, and I'm just going to put my value 1.99 as my z-score, and if I enter, I get 0.9767. Let's see if I can find my table here again. I think I might have closed my table. There we go. And so if I go to my table here and I look at 1.99, there's my 1.99, 0.9767. If I look at Excel, 0.9767. They have a couple more decimal places than they do on the table, but that's how I get that in Excel. If I want to do the area to the right, it's the same kind of thing that I had to do before. I have to do 1 minus. So I'm going to do 1 minus N-O-R-M-S-D-I-S-T. Oops, I forgot my equal. Got to put the equal in front of every formula. Equal 1 minus N-O-R-M-S. There we go. D-I-S-T. Double click on that. And then I would put in my negative 2.04. Close my parenthesis. So you can see that I have equal 1 minus because I'm going to do the area to the right. And when I enter that in there, 0.9793 is what I get. If I want to find the area between 2 numbers, again, I'm going to subtract, and I'm going to take the upper one minus the lower one. So again, I'm going to hit equal because I'm doing a formula, and then I'm going to do N-O-R-M-S-D-I-S-T. My upper one, my higher one is the 1.99. Close my parenthesis. I'm going to subtract, and then I'm going to do the NORMSDIST. And I'm going to put in the lower number, which was the negative 2.04. So if I'm doing it between, I've got to take the bigger one minus the smaller one, or the upper one minus the lower one when I hit, whoops. I must have typed something wrong. It wants to fix my extra parenthesis that I got in there. I'm going to let it fix it for me. If I have that in there correctly, I have 0.9560 to get the area between, 0.9560. Now, if I am finding the z-score that corresponds to a given area, again, I am just going to go to a blank cell here. I'm going to type equals norms with an S inverse INV. So equal NORMS, and you can see the second one is the inverse one, so I'm going to double click on that. And so if I want to have an area of 0.025, close my parenthesis and hit enter. My corresponding z-score to that would be negative 1.96, because I normally am going to round those off to 2 decimal places. On the next one there, if I have my area to the right, again, when I do the area to the right, I have to do 1 minus, but it's going to go inside my parenthesis. And so I'm going to hit equal, NORMS. I want the inverse one. And so I'm going to do 1 minus inside my parentheses. And I'm going to use 0.4567. Close my parenthesis there. So if I'm doing it the area to the right, I'm going to do 1 minus. And the corresponding z-score there is just going to be 0.11 when I round that off to 2 decimal places. If I want to find the z-score, that my z-score is between negative z and positive z, and I know that the area is 0.98, we're going to find the z-score corresponding to the cumulative area of 0.98 plus 0.01, which is 0.99. So in here we're going to do equal NORMSINV, and we are going to use 0.99, close my parenthesis there, and if I enter, you can see that I get 2.326, so 2.33 would be the area that would correspond to the cumulative area of, or that it's between, or the area in the middle is 0.98. So if my area in the middle is 0.98, again, I would have 2% left over. And so I'd have 2%, which means I have 1% on each side. And so I would use 0.99 for the area that I am checking there. I could have also done the equals negative NORMS inverse. Grab that one. And I could have done it with the 1% that I was checking. That's going to give me the negative value. So if I put 0.01, close my parenthesis, and I enter, and that gives me, because I put the negative in front, the same answer there. If I do to the left, which I didn't do on here, I'm going to do equal NORMSINV parenthesis and do my 1% there, 0.01, close my parenthesis, and then I get the negative value. So if I am finding the area in the middle is 0.98, I have 2% that's left over. 1 minus 0.98 is 0.02. I have to divide that into 2. So I have 0.01 to the left and 0.01 to the right. So I can either add my 0.01 to the 0.98 to get the area 0.99 and figure that to the left, or I can do negative norms inverse the 0.99, which gives you the 0.01, and I get the same answer whichever way I do that. And so if I'm finding the z-score that's between there, it would be plus or minus 2.33. All right, if we are going to do the normal distribution, finding a probabilities basic, which is normal random variables, finding the probability. On our graphing calculator, again, we're doing the second function, DISTR button, which is on your VARS key. And then number 2 for normal CDF. Remembering that if we're upper and lower, for upper infinity, positive infinity, we use E99. Negative infinity, we do negative E99. Make sure you use the negative key, not the subtraction key. So for example, we have, suppose the heights of adult men in the United States are normally distributed with a mean of 69.5 inches and a normal standard deviation of 2.5 inches. What proportion of adult men in the United States are at least 6 feet tall, which means 72 inches or higher? Round your answer to at least 4 decimal places. So what I'm doing is finding 72 or higher. On my graphing calculator, if I turn that on, again, I'm using the second function. So second function button over here, and then the VARS key to do my distribution menu. And I'm doing number 2. Number 2 is my normal CDF. And it gives me that where I need to type in the lower, the upper, the mean, and the standard deviation. So I'm going 72 and up. So 72 would be my lower. My upper is the E99. Again, to get the E, you do second function and the comma, 99. The mean on this one is 69.5. So I'm going to change my mean here to 69.5. My standard deviation was 2.5 inches. So I'm going to put 2.5 inches in there. So I have the lower at 72. I'm going 72 and above. So my upper is E99. Mean 69.5. Standard deviation 2.5. Whoops. There, I got to get rid of that. 2.5. Fix that. Now if I hit enter, you have that pasted into your formula. And we have 0.1587 if I round that off to 4 decimal places. 1587. Now if I'm going to do that on the Aleks calculator, we have the formula that says the probability that z is less than or equal to the mean minus, or my value that I have minus my mean over my standard deviation, which is 2.5. You got to keep in mind on the Aleks calculator, they only have the less than or equal to. So if you want to go to the right, you have to do 1 minus. Let me go ahead and go on to a problem so I can get to the Aleks calculator here. If I go on my Aleks calculator, then I am using the P of z is less than or equal to, but since I'm going to the right, I'm going to do 1 minus the probability that z is less than or equal to. And then I could calculate out that number, but if I just want to put it all in at once, I'm going to type in the 72 minus the 69.5. Oh, God, my minus didn't go. Minus. And then I'm going to highlight that so that I can divide it by the 2.5. Then I can just put the whole expression in there instead of calculating it one part at a time, which also does work. If I hit equals, you can see I get the same answers I got when I used my graphing calculator, 0.15865. So I'm going to round that off to 1587. 0.1587 then would be my answer. Now in Aleks, we don't have any that has the probability between two numbers, but basically the same thing would hold true if I'm trying to find the probability between two numbers. I'm using my normal CMD function. And so the example says, find the probability that x is between 27 and 31 when my mean is 28 and my standard deviation is 2, instead of my mean being 0 and my standard deviation is 1. So again, I'm hitting the second function button. I'm doing my vars key for the distribution menu, and I'm doing number 2, the normal CDF. And so this case, I want my lower number first, which is my 27. My upper number would be the 31. My mean is going to be 28. My standard deviation is going to be 2. I'm just going to paste that into the formula and then enter, and it gives me my value again to 4 decimal places, 0.6247, because I'd have to round it up, 0.6247, and that would be my answer if I'm trying to find it just between 2 numbers. On Aleks, most of the time you're either going to go positive infinity or negative infinity. So again, the upper limit is E99 if you're going to positive infinity. The lower limit is negative E99 if you're doing to negative infinity. The next page here, we're finding the normal distribution, finding the raw score. This case, we're going to use the inverse normal function. And again, that gives you the area to the left of x. So you have to keep in mind that if you're doing the area to the right of x, it's a little bit different. In this case, I want to find the 90th percentile when the mean is 200 and my standard deviation is 20. So I'm going to go second function again, my distribution menu on my vars key, and I am going to do number 3 to do my inverse normal. So the area under that, I'm doing 90th percentile. So I'm going from the 90th percentile down. So 0.90 is my percentage or my area. My mean is 200. So I'm going to put 200 in there for the mean. My standard deviation is 20. I'm going to paste that in. And so you see I have inverse normal, and it's going to give me the z-score that corresponds to that. Normally your z-score you round off to 2 decimal places, so 225.63 is what you'd have, 225.63. If I'm doing my Aleks calculator, I am going to use the formula that they gave me again. I'm going to go ahead and clear that out, and I am trying to find the z sub to the positive numbers go to the right, negative goes to the next. So I want to do less than 90%. I could use the negative, or if I wanted to go more than 90%, I would use 10%. So you'll notice on the Aleks calculator, I've got the first one there with the negative z 0.90 because I'm going to the left of 90%. So what I did there is I took the formula and then I calculated that out. To get rid of the fraction, we would have multiplied by the 20, and then to move the 200 to the other side, I'd add my 200. So on the Aleks calculator, I would do negative z sub 90%, since I'm doing to the left of 90%. I have to click up here. I'm going to multiply that by the 20. That was my standard deviation on the bottom of my fraction. I'm going to add the 200. And when I hit equals there, you can see I get 225.63 when I round that off to 2 decimal places. Just to show you it also works if you want to go to the right. If I was doing 90% to the left, it means I have 10% to the right. So I could have just used the z sub and used the 10% to the right. Still times my 20 standard deviation plus my 200 mean. And if I hit equals, you can see I get the exact same answer. So if you're going to go to the left, you need to put the negative in front of the z. If you're going to the right of that value, then you don't need that in there. So another example straight off of Aleks says a newspaper article reported that people spent a mean of 7 hours per day watching TV with a standard deviation of 1.8 hours. A psychologist would like to conduct interviews with the 20% of the population who spent the most time watching TV. She assumes the daily time people spend watching TV is normally distributed. At least how many hours of daily TV watching are necessary for a person to be eligible for the interview? Carry your intermediate computations to at least 4 decimal places. Round your answer to 1 decimal place. So I want to interview the top 20%. If I'm doing the top 20%, I'm going to do 80% or lower. So on my graphing calculator, I'm going to do my second function button and my vars key to get my distribution menu. And again, we're going to do number 3 to do inverse normal. So if I do number 3 there, my area, I want 80% or lower. Since I want the top 20, I'm doing 80% or lower. My mean was 7 hours. My standard deviation is 1.8 hours. So the area under the curve, if I'm doing 80% and then 7 and 1.8. If I paste that into my formula and I hit enter, I have 8.51. 8.51 is what I get on my graphing calculator. On the Aleks calculator, again, you're doing the formula. Z minus 7 over 1.8 equals Z sub 0.20 because I'm doing the top 20%. If Z is positive, I'm going to the right. So multiplying that out, I would do the Z sub 0.20 to the right. Click up here. I'm going to times that by the standard deviation, 1.8. I'm going to add the mean, which was 7. And when I calculate that out, I get 8.51, rounding that off to 2 decimal places. Oh, it says 1 decimal place on Aleks. At least 1, or so 8.5 is what we'd want to do. Again, it also works if you do the negative. If I'm negative, I'm going to the left. So if I'm doing the top 20%, I'm going to the left of 80%. I would do negative Z sub 0.80, and then again click up, multiply that by the standard deviation of 1.8, and add my mean, which is 7, and I can see I get the same answer, 8.5, when I round that off to 1 decimal place. The next one says we want to construct a normal quantile plot. We're going to enter our data values into list 1. So again, I'm going to clear out my calculator screen. If I'm entering my data values into my list, I'm going to hit my stat button. So I'm going to hit stat. I'm going to hit 1 to edit. If there is anything in there, highlight L1, hit clear, and enter. Mine was already cleared, but if you need to. And then we got to put our data in there. So I'm going to type my data in there. 5, 29, 34, 44, 45, 63, 68, 74, 74, 81, 88, 91, 97, 98, 113, 118, 151, and 158. So I've got my numbers all typed into list 1. And it says to do the stat plot. So we are going to hit the second function and hit the Y equal button to do the stat plot. Second function Y equal. Now I'm going to do number 1, but instead of doing a histogram this time, I am going to do the 6th graph. It says, if I go on here, first of all, I want to make sure my stat plot is on. If it's not, turn it on. The type, I'm going to go 1, 2, 3, 4, 5. That 6th one over should be the very last one. So I got the very last one highlighted. Go ahead and make sure list 1 is in there for your X list. If not, you would hit second function 1 to make list 1. Frequency, we're just going to leave at 1. And I am going to just enter through that. And now I have to hit my graph button. So if I hit graph, whoops, what do I still have on here? I have my histogram. I must not have hit enter on there. Let me try that again. Plot 1, I want to enter on that one. I didn't enter. There we go. We have list 1. Our data axis is X. We can have what kind of mark we want. And now if I hit graph. Now, when I hit graph, I don't see anything on my screen because I have to change my window so that it is adjusted according to my values. So I'm going to adjust the X minimum and X maximum according to my data values. So I'm going to hit window, and 5 was my lowest data value. So I'm just going to start it at 0. And 158 was my highest data value. So I'm going to put 160. And let's just use a scale of 10 and see if that looks okay. It says for the Y minimum, let's use -3. Be sure to use the negative, not the minus. The Y maximum, +3. So here's what I have in there. I'm going to hit graph and see what we get and see if it fits. That looks pretty good. And so I have my stat plot in there. And you can see it says, is this set of data approximately normal? Well, it's approximately normal if it looks like it's pretty close to a straight line. And if you look at that, yeah, they all line up pretty close to a straight line. You've got a couple on the end that are kind of thrown out there in a weird spot. But it is approximately normal because my graph looks like a straight line. And now we're going to do the same thing on Excel. So I'm just going to go to this next tab here. Again, we have to put our data into our list here. And so I'm going to enter my data into column A. 5, 29, 97, 98, 113, 34, 68, 74, 74, 81, 88, 91, 44, 45, 63, 118, 151, and 158. So I've got my data in there. After all the data has been entered, I'm going to sort column A. So I'm going to highlight those values in column A. If you remember when we did sorting, I am going to go to my Home tab, the one up here on the top that says Home. I'm going to go to the right that says Sort and Filter, and I'm going to sort them from smallest to largest so I have them sorted in order. So I have my data entered. I sorted them out. I'm going to select cell B1. And in cell B1, I am going to do the inverse normal. So I'm going to hit equal, equal. I didn't get my equal. NORMSINV, the inverse normal. And I am going to do the inverse normal of 1 divided by 2 times 18. Close my parenthesis. So, it says since the sample size is 18, each score is 1/18, or approximately 5.6% of the sample. That's why we use the 1 divided by 2 times 18 there. Each data value is assumed to subdivide the data into equal intervals. The data value corresponds to the midpoint. Thus, the procedure will standardize the data by assuming that each data value represents the midpoint of the width 1/18, in other words, 1/36. So I'm going to enter there. Oops. And evidently I typed something in there wrong. Let me look here. Inverse equals norms inverse. Oh, I forgot my parentheses around my 2 times my 18. That's what I didn't do. Parentheses have to be around that so that it does the 2 times 18 first, or I could have prevented that by just using a 36 underneath there. And then I have the value that goes corresponding to that. And so basically I'm going to repeat that for each subsequent value in column A, entering the next odd multiple of 136 in the argument for the normal function. So in cell B2, I'm going to have the same formula. I'm just going to copy Control C and paste it in here, but I'm going to change the 1 to a 3. I'm going to go up by odd numbers. And so I have negative 1.38, and I can just keep doing that. I'm just going to go ahead and copy Control C and paste this down the way. And then I'm going to change them to the odd numbers. So in cell B3, I'm going to change the 3 to a 5. And down my way, 7, 9, and so forth. And the last one should be your 35. Get that in there. All right. So I put my formula in there. And again, I could have used this 36 because there's 1/18th on each side. So 1/36. And change that top number to every odd number. So 1, 3, 5, 7, 9, so forth, all the way up to my 35, which I've got in there. So now it says to highlight the data from columns A and B. So I'm going to go ahead and highlight columns A and B. And select the insert function. And I'm going to insert a scatter chart. So I am going to go to this one right here. Insert scatter, X, Y, or bubble chart. Insert scatter chart. I'm going to hit my little arrow here. And I am going to hit select the scatter with only markers, the first scatter chart. So this very first one that just says scatter on it is the one I'm going to pick. And you can see that I have my scatter chart there. If I would want to insert my title in there, again, I could go up here and change my title. And if I want to label my axes, I would want to pick the different layout. So again, if I double click on here, I was trying to find the one that gave me different format here. Go to insert. Left click. Any region, select chart tools and layout from the toolbar. It is not giving me my chart tool menu. Probably because I have my thing smushed. There it is. If I hit design, if I go to design on here, I can then go to my quick layout, and under my quick layout I can select one that has the titles. I'm trying to find one that gives me all of them. I find it better to pick one that has more stuff than you want instead of less stuff than you want, because you can always delete them off if you don't want them on there. Here I'm just going to pick this first one here to get my chart. If you want to get rid of the series, again, you can just click on that and delete that, but then you can change your labels. It says change the horizontal axis title to number of days of inventory. So I could go here and change that. I could delete the vertical axis title, it says, so I got rid of that. Tell me what to name my chart. I'm just going to call it the normal quantile plot. There, I changed my name. I've got my dots on there. Again, if you look at your plot, if you look at that, those dots all are pretty close to a straight line. So if they ask you, is this normally distributed? Yes, all my dots are pretty close to being in a straight line. So I would say yes, it's pretty close to normal. So it's approximately normally distributed if I look at my dots here. And then it says print your active sheet and be sure to change the orientation and scale so that it fits on one page. So if you need to slide that over, if I go to File and I print, oops, I got my chart selected. I always do that. File and print. When nothing's selected, if it doesn't quite fit on there, change it to landscape orientation, and then everything should fit on there. We can see your data as well as your chart. Go ahead and print that out.